Hello everyone. This session is about catabolism of proteins. The protein contains a nitrogen molecule which is disposed as urea in our body. So in this session we'll see how the proteins are degraded and also the urea cycle and the disorders related to the urea cycle. So proteins, it is a tissue building component. It contains amino acid. Amino acid is the basic unit of proteins. They are built up together using the linkage peptide bond to form the proteins. So it contains a nitrogen group and it is having a diverse function. Proteins are having diverse functions. They can be an enzyme, hormones, and it has transport and structural proteins. Like your glycoproteins act as a structural proteins, transport proteins like your hemoglobin, transferrin, etc. Immunoglobulins are the proteins which produces immunity to our body. So most of our body components are proteins. But the proteins have no stores in the body, whereas your carbohydrates have storage form in the body like glycogen, but the proteins have no stores in the body. So it is always in a transient state. Okay, so body protein content is not static but exists in a dynamic steady state. This dynamic steady state transformations are brought about by two important concepts. One is the amino acid pool and second is protein turnover. The proteins have no permanent storage, whereas it can be transiently stored in a pool called amino acid pool. Next, the concept is protein turnover. Protein turnover means the rate of synthesis and degradation of proteins are equal, so that it maintains the nitrogen balance. So that whenever there is a rate of synthesis, it is balanced by a rate of degradations, so that the nitrogen balance is maintained in our body. The amino acid pool is in a dynamic steady state. It contains 100 grams of proteins. So it is always in a dynamic state. Something will be coming in and something will be coming out. So which are responsible for this amino acid pool or degradation of the body proteins? 3 Ds are very important. One is degradation of body proteins, dietary protein. Digestion of dietary protein will give the amino acids. And third thing, de novo synthesis of amino acids. So these are the 3 Ds which are responsible for the amino acid in this pool. So the amino acid pool output is given by synthesis of body proteins, synthesis of nitrogen molecules like your biogenic amines, non-protein amino acids, and catabolisms. So here the degradation of the body protein is equal to synthesis of body proteins. This is called as protein turnover. So it should be in a steady state. Whenever there is excess amino acid, surplus amount of amino acid, it undergoes degradation to the catabolic pathway which is excreted as urea. Okay, only the nitrogen compound of the amino acid excreted as urea. What happened to the carbon skeleton of the amino acid? They can be degraded to either glucose or fatty acids. So next, in this class, we'll concentrate on the catabolism of amino acid. So amino acid pool is supplied by 3 sources. One is degradation of the body proteins, second D is dietary protein, and third one is de novo synthesis of non-essential amino acid from simple intermediates of metabolism. Amino acid pool is depleted by 3 routes. One is synthesis of body proteins. Second one, amino acid consumed as precursors of essential nitrogen containing small molecules. Otherwise, we can generate biogenic amines. The third one is the catabolic pathway. Whenever there is surplus amount of amino acid, it can be catabolized by two ways. The carbon skeleton can go to the formation of glucose, fatty acid, ketone bodies and completely oxidize to carbon dioxide and water. The nitrogen group of the amino acid is disposed as urea. So this is the catabolism of amino acid. So this is the amino acid structure. The central carbon is the chiral carbon to which 4 different groups are attached. One is the carboxyl group, second one is the amino group and third one is H, fourth one is the R side chain. So what is the fate of carbon and nitrogen skeleton of the amino acid? The carbon skeleton goes for oxidations. That is why the amino acid classification, in amino acid classification we have seen one classification is based on metabolic end products. It may be a glucogenic amino acid or a ketogenic amino acid, otherwise both glucogenic or ketogenic amino acid. So it is oxidized glucose or ketone bodies. Otherwise fatty acids which can be completely oxidized to give you carbon dioxide and water. So what happens to the amino group? It is the waste disposable. It can be disposed as urea.